Hello everyone. Again welcome to numerical series of utilization, and today our numerical problem is an electric train has quadrilateral speed time curve as follow. Uniform escalation from rest at 2 km per hour for 30 seconds and costing for 50 seconds, braking speed for 20 seconds. The train is moving up gradient of 1%. Tractive force is 40 Newton per tons. Rotational is 10%. The dead weight duration of a station is 15 seconds, and overall efficiency of transmission and gear and the motor are 75. Calculate the value of its schedule time and a specific energy consumption of the run. So first of all, write all the given maximum speed v1 alpha into t1 2 into 30 60 km. Costing retardation beta is 0.452. So v2 equal to 37.4. Braking retardation beta equal to 1.8. Total distance s equal to 1.03. And distance travel when power is 1, that is s1. S1 equal to distance travel during acceleration. So b1 t1 upon 7200, that is 60 into 30 upon 7200, 0.25 kilometer. And a specific energy output, this is the formula for a specific energy output, that is 0.01072 upon s bm square into we upon w plus 0.2778 98.1 g plus r s1 upon s. And so put all these value. After putting all these value, we can get 50.5 watt hour per tons kilometer, and specific energy equal to this upon efficiency. So 50.5 upon efficiency is 75%. So 0.75. Then we can get a specific energy consumption is 67.34.